Hi, we are Group 19. In this project, we built an opinion retrieval and sentiment analysis system using Reddit as our data source. Our team has 5 members, and each of us contributes to a different part of the project, from calling the data, indexing it, building the interface, and finally classifying the comments. Here's a quick look at what we'll cover. First, how we cloud and cleaned the Reddit posts and comments. Then, how we index everything and build a search interface. And finally, how we use the machine learning to detect sentiment and sarcasm. As for our topic, we chose RO on population opinion, a subreddit where people express thoughts that go against the norm. This gave us a diverse and sometimes emotionally charged dataset to work with. Our motivation was to create a tool to help users explore different viewpoints, especially when they are usually underrepresented, through a clean and user-friendly system.
Next, I will be presenting about how we index and crawl the data. To crawl the data, we use the Python Reddit API wrapper or p-raw to fetch the data from the unpopular opinion subreddit, retrieving the top posts of all time along with their associated top-level comments. Here we exclude the nested replies to the comments, and once retrieved, the data was stored in CSV format and separated into 2 datasets, one for posts and one for comments, which allowed us to process them independently during processing. We begin filtering out any empty, bot-generated, duplicated, or overly short comments, which has less than 30 alphabetical characters. Next, we cleaned up the text with microtext normalization, converting the emoticons to words, removing URLs, div links, and special characters. We also expanded the contractions from your to your and replaced the common abbreviations and snags. We ran spelling correction on a tokenized text, except for tokens that are identified as name entities. And here are some examples of the text before and after pre-processing. For indexing, to build our search engine, we use Whoosh, a Python library for fast and flexible text index. We indexed key fields from our dataset like comment ID, post ID, comment body, and predicted the polarity, so users can easily search and retrieve relevant content. For the user interface, we created a simple and responsive Streamlit app which connects directly to the Whoosh index. This allows users to type in search queries and get real-time results without a need for a complex backend. It is lightweight, scalable, and easy to use. To enhance the search experience, we implemented 3 key features. First, a timeline search, where users can filter results by start and end dates. Second, spell correction. Our system suggests corrected queries when no results are found. And finally, custom result ordering. Users can sort results by relevance, newest or oldest posts, or even by upvotes.
Our 2 classification tasks for polarity and sarcasm detection. For polarity, our goal was to classify them into positive, neutral, or negative sentiments. Our training dataset was a combination of Reddit data from Go Emotions, Amazon reviews, and tweets used in the Sam Ebell benchmark. We fine-tuned pre-trained LLMs like BERT, Roberta, Twitter Roberta, and XLNet. The best model was Twitter Roberta, which achieved accuracy of 0.62. Next, we trained our sarcasm model on a subset of the sarcasm on Reddit dataset. We fine-tuned T5, BERT, and Roberta models. BERT was the best model with 0.29 F1 score on the minority sarcastic class and 0.78 accuracy overall. Here are a few ways we sought to improve the polarity detection task. Firstly, we incorporated sarcasm detection by setting polarities to negative if sarcasm was detected. This boosted F1 scores for the negative class to 0.72, but this method assumes that sarcastic comments should always be negative and may miss nuances that suggest otherwise. Next, we tried max voting ensembles with different combinations of 3 polarity models. One ensemble, comprising variations of Twitter Roberta trained under different settings, improved accuracy to 0.63. Another ensemble comprising BERT, Roberta base, and XLNet improved neutral recall to 0.54. Lastly, we trained Twitter Roberta with name entity recognition. Neutral recall increased from 0.51 to 0.61. Positive precision also increased from 0.61 to 0.64, but overall accuracy dropped due to drops in other classes from 0.62 to 0.6.
Now, let's move on to the design of our application. This is how our application looks like, and this will be where the user inputs the search query. Let's input a sample query like pineapple. As you can see, when there's a misspelling, the spell checker will come into place with autocorrection. After clicking search for pineapple, we can then see the results. Each record shows the post ID, number of upvotes, the predicted labels, post title, post body, comment body, as well as time of comment. At the side, we can also see a pie chart and a word cloud, which gives an easy visual representation of the distribution of data, as well as the related comments. Let's try another sample query for more results, like these are stupid. As you can see at the side, we also have many filter and sorting options. Firstly, we can filter by dates of comments, as well as the number of upvotes. We also can set the number of results to display. For sorting options, we can sort from the newest to oldest, as well as from the number of upvotes in ascending or descending order. Lastly, we also can sort based on the predicted polarity and sarcasm labels by our model. At the top, we can see the number of raw data before and applying the filter, which makes it useful for evaluating such the comments.